Hey guys, welcome back to the peer-to-peer network coding session. This is episode 12, and today we're going to be we're going to be working on we'll be working on the permission network so that we finish the infrastructure level and we enable permission networks fully. So what I mean with that is what we have defined here as permission peer-to-peer networks. As we have defined here, we are going to implement the code needed in order to check these permissions. Okay. There is also some other pending stuff at the peer-to-peer network level, and is that at the HTTP interface we are not checking we are not checking the signatures of who is sending this stuff. So let me review that first. Hold on a second. Okay, so there is this concept of client interface where we receive the signal, and also there is this validate signatures. So I'm wondering if no, because the signatures that we are validating here, let me rationalize this. When we have these ongoing signals, we are when we got this, we are signing the signal with the user app and the social trading bot that is sending this. I want to check when and how we are checking when things can be a WebSocket, so that everything gets like standardized. Okay. Okay, so when a message can be a WebSockets, it comes through here. In the case of WebSocket, because there is an open connection, we have this handshake procedure where we check the identity of the of whoever is whoever is sending the message. Mhm. So we need the handshake to be done before receiving requests. Okay, so that's a different story. Because you establish a connection and you keep it open, so you do this validation once. Okay, I'm not going to go into that point right now. Let's see how we implement, in the case of permission networks, how we implement these permissions themselves. um, so the work we did so far for distinguishing between public and closed networks, the work we did so far, where was that work? It was in here, peer-to-peer network. So let me check that to see where we are in terms of that. Peer-to-peer network. So this module represents the peer-to-peer network and is needed to enable the connection of the current node to other peers. The main feature here is the array of nodes that we can potentially connect to. Okay. So this stuff is what is right now filtering who we can connect to. But this filter is applied on the client side of the nodes. That means, or on the client app, that means if I am going to connect to the network, this code is going to filter all the nodes that are not belonging to the network I want to connect, if it is either open or close, or which network in particular. But we haven't implemented the counterpart of this code inside the network node, that is the actually one preventing a user profile to connect to a network that, if it is not open, then it should have explicit permissions to connect to. Okay, so that's where we're standing now. We have that at the client side, we are filtering out, but we have to check that at the server side, because somebody can remove these constraints and still try to connect somewhere where they don't have permission. And not even that, because we are not checking here if the network is a permission network. We are not even checking that we have permission for that. Okay? Okay, so there are kind of three things missing. The permissions, we are not checking it at the client or the server. And the type of network, the matching, is not checked at the server side. Okay, so for example, and there is a matching that it needs to be checked at closed networks, because open networks you can add a node without permission. Okay, so there's no problem with that. Um, so this has a lot of implications, because it's not only a client-server situation between applications and network node, but also between nodes themselves. So let's try to rationalize this again. At the client side, at this peer-to-peer network module that is used by any network application, the desktop app, tax server app, or even a network node, we are filtering out who we can connect to. Okay, so I guess that one of the things we have to do is at the WebSocket interface, we have to be very clear which type of network this node belongs to. Okay, uh, okay, so we need to know which type of network the node we are running belongs to, in order to be able to check that incoming connections come from people with permission. Okay, um, so let's try to find where do we have this information. We know that at the user profile we have these peer-to-peer network nodes, and we have a reference to this node. Okay, and here something that tells us which network is this referencing. So where are we storing this stuff? It is here at peer-to-peer network node. So I'm going to clear a little bit this stuff, because I'm not going to be working with this. Not right now. So okay, so this is the node, this is the module that is holding the node, okay? And it's also certified by this that we can access the information of which network we are in and which type of network we are in. Maybe instead of putting all this long reference, maybe I should move this into properties of the object. Okay, so that is the first thing I'm going to do, so that is not so indirect, because these are very important information. So this is the, the node, representing the node, but I'm not sure if I'm going to move it, because then I have to maintain that information and depend on information that it probably hasn't played well, that technique of putting a simplified path of stuff. I'm going to keep it like that. So mm, okay, so I can essentially I can say that this is the this is the network type. Okay, so I got the network type. So I have to review the procedure of authentication, the authentication procedure, so that I only let somebody to connect to my node if they have permission, in the cases where I am a node of a permission network. Okay, so where is that happening? Handshake procedure. The handshake procedure have two steps. We need to know which one we are at. Okay, handshake procedure 1 or 2. Okay, at one point we will know which is the user profile. I'm looking for the place where we get which is the user profile, and when we verify the signature gives the blockchain account. Okay, so here we have the user profile of the guy that is calling. Okay, and we are sending a message that the handshake is successful. Okay. So what I want to do is to insert more validations depending on the type of network. So I will move this guy to here. This is probably something that goes in here. And here we will check that if we are a node of a single network, that whoever is connecting to us has the mission to do so. Okay, so essentially if essentially what we are saying is that if this reference is pointing to a node of this type, permission peer-to-peer network, then we will need to check the permissions. Okay, and how do we do that? Well, we have the user profile. Remember that the permissions are in the end references to user profiles. Okay, so the first thing we will need that we don't have is a map with all the profiles that have permission to this network, to the network we belong to. Okay, and we are not going to calculate this here because it needs to be calculated only once. That's part of the, yes, you guess it, the bootstrapping process. Okay, so the bootstrapping process is scanning all user plugins for information that is needed. One of the things that is scanning is which is the network node, which are the network nodes, all the network nodes. Okay, So, what information will we need? Because the bootstrapping process doesn't really know if it is being executed at a client app or at the node itself. So, what information we actually need? Well, we need is what we need what we need is all the profiles, a map that points to all the profiles that have permission to the same network if we are a node that we belong to, if it is a permission network. But if you're not a network node, you need to know or we will need to know all the private networks I have access to. Because then when I'm looking for nodes, I might want to have a pre-created list of all the nodes of all the networks I have access to, so that I don't even try to get to connect to a node or a network that I'm not welcome there. It's like two different problems, okay? So based on my profile, so there are two type of problems. Based on, if I am a node, and how do I know if I'm a node or not? And how do I know which is the user profile of whoever is running this application? User app code name, peer-to-peer network client identity. So at the secrets file, I might have that relationship of which are all the, which is your user profile based on this information that we already have. Okay, let's take a look at the secret file. Remember that the secret files can be generated, these sign-in account secrets, many times. So there is not a big deal if you have exposed your secret file, because you can regenerate all the private keys and sign all the accounts again. Okay, so I will do that after the video. But essentially, the secret file is where we already have this configuration and this relationship between the application that is running and the user profile ID. Okay, for example, let's try to rationalize this a little bit more. We are running a network node, right? So we are going to receive here the user app code name, let's take a look at how this works in detail. So I'm going to open secrets. Okay, when we create this map, signings map, what we are doing is the node code name, we are using it as a key. Okay, so we are going around all these records, and what is called node code name, this is used as a key of the map. So when we are receiving, when we have this at the environment, and we're receiving that this is the node that we are running, this is the node code name, then we get access to all this record. Okay, so we have the node ID, node name, node type, blah blah blah, the sign-in account of this node, blockchain account, the private key, also the profile handle and the user profile ID. We have access to everything because we had the node code name that was at the environment file, right? Okay, so with that, we can know if we are in a peer-to-peer network node or not, because we get it from this record. Okay, if it were a task server app, then it would tell me that I am a task server app and not a peer-to-peer network node. Okay, so what we needed to know at the bootstrapping process was essentially, if I am a network node, then I need to build, if I am a network node that is part of a permission network, then I need to build a list or a map with all the profiles that have access to this network, so that then I can control it at the WebSockets interface, okay, and the HTTP interface. So that means that, but if I'm not a network node, if I'm any application, I also need to know okay, if I'm any application, I also need to know or to have a map of all the networks that I can connect to, because the filtering mechanism that we have to see which nodes that we can connect to, it has to take into account who we can connect to. And that is based on permission for permissioned peer-to-peer networks, okay? So now it's getting a little bit more clear. All these functions are running inside this extract information from user profiles. Okay, but this information, the first information I need to build is if I'm a network node. Okay, so we are going to create here a new function. By the way, I don't know why this is asynchronic function. Because it's not having asynchronic operations anymore. I will remove this. And now we will start coding. Okay, this one's not even called with an await. Okay. So extract information from user profile is good, but in the first case, we don't need to extract information from user profile. We need to set up user networks. Okay. So again, what we need to do is to, if we are a network node, so let's write this. If we are a that is part of a then okay, so this is what we have to do. So if we are a peer-to-peer network node, how do we know that? What we're going to do to know that is what I was just said. We'll come here, and from the secret file, based on this app stuff, we are going to extract the node type, not the node ID. So if this is equal to this, that means that indeed we are a network node. Okay, good. Or I'm going to do it on the contrary. If we are not, then we leave this function. It's not for you. Okay, the next thing is, well, probably I exaggerated with this because at this point we already have the node at this guy. So peer-to-peer network client identity node already had the node so it has a reference to this node, and we're going to use this one because we're also going to need this guy. Okay, so if it is not a peer-to-peer network node, goodbye. Then we will need something like this. But as we have this guy, I'm using this because this is not part of NT but SA, meaning that it's reused by other applications. So if this guy node reference parent or reference parent dot type, if it is not a permission stuff, then return. Okay, then return. But if we are a node of a permission peer-to-peer network, then we will need to build a map. So how are we going to build a map? Maybe one of the things we will need is this user profile, that I don't see that we are storing this stuff anywhere, and I don't want to go and find it. So maybe when we are setting up this guy, we should also store there not only the social profile, but the user profile too, because we have it here. Do we have it? Yes, we have it. So we are going to upgrade this guy to save information that we need to access easily, including the user profile. Okay, so this addition here means that we need to come to two places. One is this and the other is this, because these are very similar modules. This is when we are a node, and this is when we are a client, a network client. Okay, but in both cases we have to add the user profile here and here. I don't like this distinction because nowhere else we have that. And also the initialize, we will put user profile user profile. Okay, so this will come here, and this will come here. Okay, so this means that we will have here dot user profile, the user profile node here. But hold on, we need the user profile, not my user profile, or the user profile of the node. We need we didn't need the user profile at all. We don't need the user profile at all. What we need, in fact, is this node, and from this node, no, we need this node, that if we are referencing this, we already have it. And from here, we can get all the permission granted people. Okay, so that was my mistake. But anyways, I'm not going to undo this because it's most likely going to be useful to have not the ideas in the secret file, but the actual reference to the profile where this node or this app belongs from. Because from the profile, you can go and search for any other information. Okay, so I'm going to leave that there. But actually, what we need is let permission granted. Alright, is going to be equal to, and here I will need a function to scan all these nodes and give me an array of a certain type, and we already have that. Maybe at the visual scripting is a node functions scan node branch, no, node branch to array. So I will need an example of this. We have one very close because we are using this stuff here. Amazing. So essentially what we are going to do is to look for this type of node, permission granted, in this, starting in this network node. So anything down the line will be scanned and we will get an array of all the permission granted. So this is going to be the starting node, which is the peer-to-peer network that we are referencing. Okay. So then I'm going to iterate over this guy. Well, and I will need a global variable where to store this guy, a global map. For example, like this one. What I'm seeing here is that on one side I need the people, the user profiles that have permission to the network. So a map by user ID that tell me if they are there or not. But then I will need also a map by network ID that tells me if a user is there or not. So what I have here is, what I need here now is permissions granted by user profile ID. So the explanation of this is that we will store the user profiles that have been granted permission to access currently running permissioned via network. Okay, so this is it, and this is going to be, of course, a new map. So here we found all these nodes permission granted, but we are not sure that this guy actually have a reference parent. So we're going to filter out the ones that don't have it. If permission granted okay, so then that is gone. Then we can say that these are the actual user profiles that have permission, right? So this is what we're going to record in this map by their ID. And just like that, we created a map. We created a map with all the user profiles that have permission to access our permissioned peer-to-peer network. Okay, so this comes here, and after we are sure that this is the case, we set up permissioned network. Okay, okay, so now that we have a map, everything turns quite easy, because if we go to the WebSocket interface and we detect that we are a node of a permission peer-to-peer network, and we have a reference to the user profile that is communicating with us, then we could say we're going to get, and we're going to use this guy ID to retrieve this stuff. But if this happens to be undefined, that would mean that we cannot actually grant permission to this guy. So we will generate a specific error message user profile does not have permission to this permission peer-to-peer network. Okay, we send a message and we return, and game over. Okay, so this is the way we check at a permission peer-to-peer network that you actually have permission to connect via WebSockets. Okay, so what happens when someone connects via HTTP, the HTTP interface? So we have, let's write it down because we're going to put these nodes here. Um, okay, so the pending things we need to address is allowing or controlling permissions at the HTTP interface. Another thing that we need is um, to filter the peer-to-peer network nodes we can connect to based on the permissions we actually have to permissioned networks. Okay, so today we have no filtering, so we will try to connect probably to peer-to-peer networks that we don't have permission, which is not clever. Okay, so let's take a look at the HTTP interface to see if we are going to be able to do this now. Here is the Websocket interface. The HTTP interface is less developed. The way that we know of the WebSockets interface who is calling is because somehow, not somehow, but it's because the caller is signing the message with an identity that we know that belongs to a certain profile. So let me understand this, because it looks like we will have to do a similar stuff for the HTTP interface. We'll check the signature of the message. Okay. So signature not provide. The signature give us the blockchain account and the account user profile. In fact, it doesn't give us the user profile, it gives us the blockchain account, and because we have a map of user profiles by blockchain account that we build during the bootstrapping process, then we can have which is the user profile. Okay, so we need to check the signatures inside the HTTP interface, and today we are not doing that. The signatures are going inside they are going inside to this client interface. That is this the interface of trading signals. Okay. Okay, so I'm going to commit what we have now. There is essentially again. So trading signals have this client interface. Then I'm going to put it down here. Validate signatures is a function at utilities of trading signals. I'm not sure that is the place, but let's see. Let's have projects, signal validations. Validate signatures. Okay, so we are doing the stuff. But we are doing it at the wrong place. And we are getting, so we validate that the signal belongs to some user profile by extracting the blockchain account of the signatures. But signature not linked to a profile. Social trading bot, but signature. Social trading bot not linked to a profile. Okay, so maybe there is something here, because the social trading bot signature is likely okay here. The problem is with the application signature, the user app signature, that this is not belonging here. This belongs, this check needs to be done at the HTTP interface. Essentially, that is the situation. But that also means that the place in the message where the signal is not appropriate. Okay. So to fix this, we will need to go to the guy who is actually sending the message. Okay. The guy who is sending the message. Maybe this guy. Okay, here are produced the two signals, the signatures. The signal should be signed by the trading bot, the social trading bot, that is actually the entity producing the signal. Okay. But the user app, the signature of the user app, it doesn't need to belong. It doesn't belong here. This signature needs to be. So where is the user app coming? Okay, I will reorganize this stuff. So far, the only information that is actually being used is this, so I can play with this stuff. So I will move this to this level. And all this information about the user app, which is really not needed, is it just information, plus the signature of the user app. It's going to be moved somewhere else. So the next guy in this stack is peer-to-peer network start. So when we are going to send a message, we have the network message header. So we are going to reorganize this stuff. The signal is going to become the payload, and Maybe I will do the same stuff that I have this already initialized in case it has any advantage at all. Okay, now that we have this Web3, we're going to move everything that says user app The question is what we are going to sign exactly. Maybe the user profile or what? The user app, because we are talking about this now. That there is a user app like, for example, this guy. So we're going to move this stuff. We're going to move it here. And the broadcaster, that I'm not going to call broadcaster, but just user app. The broadcaster would mean that we are talking about specifically about signals. I'm going to say I'm going to send this information that is actually not being used for anything. Um, Maybe I can sign this. Or maybe I can sign this. We will see. So from the signatures, I will remove this. And then I will so the signal is signed by the social trading bot, which makes sense. And the message that is going to be broadcasted or sent via the HTTP interface is going to be signed We're going to sign this because it doesn't really matter exactly what we sign. And we're going to place it here, signature there. And the other one, we're going to place it just signature. Okay, so we got a social trading bot. Okay, so this gets a little bit more consistent. Okay, so this is good. This means that in these signal validations, this we are going to do it inside so this is going to be just signal signature. So first I'm going to remove the stuff that is related to the user app. Okay. Okay. So we are going to go to the Websockets interface and not the WebSocket, the HTTP interface. And now we have to decide where we are going to check these signals, because we have these messages ping that are not going to be signing, but it's very lightweight stuff. But okay, it's obviously the request, a new message. So this validation is not in the right order. So here we're going to validate signatures. Validate the signature. User app signature to be more specific. So the message header, we have a property called just signature, and this should recover a blockchain account, otherwise user account, but signature, and we need to respond like this. Okay, then we will get, but this is user's social profile by blockchain account. I need a user profile. What do we have here? WebSocket interface. But this is incorrect. Witness user profile. Why am I using a user social profile? There's a bigger problem here. There is a mixed up between user profile and user profile, social profile. Oof. There's a problem. I cannot use a social profile at this level because the WebSocket doesn't understand about social profiles. My God. There is another mix with the profile handle. The profile handle is not the same as the user or the social profile handle. So there is a big mess here. So this is not going to work because we are not having a user profile. It's a social profile. That doesn't make sense. So I'm going to finish what I'm doing, but then we will have to fix this stuff, and it's not going to be that easy. So let's pretend this is a user profile. Hmm. Okay, so let's continue this logic. If this is not good, then you're going to return. So essentially, we are recovering the blockchain account from the signature, and with that, if we cannot recover a blockchain account, we return an error. Then we will get a user profile based on that blockchain account. If we cannot do it, we return an error. And if we have a user profile, then we are going to be able to execute and distribute the signal. Okay. Okay. So this is what it was missing here. So we go back to signal validations, and what we have is we check that the entities sending the signal belong to some user profile, the same trick, because this is a signal validation for a signature validation for the signal themselves. So from the signal signature, we get a blockchain account. From here, we should get use a social profile to do. In fact, we should get a bot profile because the signal or a user profile. We haven't signed the file key, so this is not going to be true. The signed message is, in fact, well, yes, we have signed this file key. But this is going to fail because it doesn't exist here. So we're just going to put file key. So many things that can fail here. So this should be equal signed message There were two signatures before, now there is only one. Well, I know very much sure what I did here. So let's recap. What we were trying to do is at the HTTP interface validate the signature of the user app sending this request when we have this type of request. Okay? But we realize that the signature was coming not at the message header, but at the signature object itself, at the signal object itself. So that end up somewhere else at another layer, but we need to validate it here. That means that we had to correct the place we were signing, that is here, moving part of this into here, because here is where we assemble the message header. All right, so we reorganize this message header. It has the network service, this information that we don't actually use, the signature, and the payload that is the actual signal. Maybe I should remove everything that is not actually needed, because why do I need it if it's with... Well, maybe for statistics. I cannot see why I need this. Mostly for debugging purposes. To know who is sending this if we are debugging at the network. Okay, I'm not going to delete it now because for some reason I thought about that and put it there. Okay. So we are signing this here. And this is getting in here. Why I needed the user profile? Because I needed, with the user profile, I needed to check. Made the same validation here. If we are at the permission network, blah, blah, blah. But that was the point of all this. This is what we start trying to make it work. Okay. So here is not going to be caller user profile, but just the user profile ID. So if we are at the permission network, then we get this, and if this is undefined, then we will respond with this user profile does not have permission to this peer-to-peer. Okay, so this is it. Okay, so I have implemented the validations of permissions at the Websockets interface and at the HTTP interface. While doing that, I realized that at the WebSocket interface and now also at the HTTP interface and probably at signal validations, okay, there is a problem that we are mixing the concept of user profile with user social profile. And by mixing these concepts, that was probably not relevant before because we just needed to know if that entity existed. But now we need that this entity exists and also have permissions. So it's not going to work while it is mixed. So I will need to take note about this, that we will need to resolve the conflict created at WebSockets Interface, HTTP interface, and signal validations. This is trading signal. Where the concept of user profile is mixed with the concept of user social profile. Okay, it's mixed up. So because it's mixed up, this is not going to work. So I need to fix this first and then debug all the code written to check for permissions. WebSocket and HTTP interfaces. Okay, and after that, I will need to filter the peer-to-peer network node that we can connect to based on the permission we actually have to permission networks. And with that piece put together, then we have permission networks fully. Okay, so 3 pieces, 3 more steps to go, probably 3 more coding sessions to get to permission networks fully implemented. Okay, so before I forget, I will commit these changes. This implementation of missions, the HTTP interface. Okay, and also I will come I will come to the other workspace, the network demo. I think I put it network peer-to-peer network demo. And I will regenerate the the secrets file. So for that, I have my profile constructor linked to my profile, and I will do an install sign-in accounts. So sign-in account secrets file have been successfully created. So this overrides whatever I had before. That means that all the private keys that you have seen are not longer valid. So this is the end for now. We have yet 3 more steps towards the goal of permission networks. Well, thank you for watching this one. See you at the next one. Bye.